Hello and welcome back. This is our first video for the new year and the second semester. This one is over the sun, and the sun is our closest star. The sun is located in the center of our solar system. So as you can see, here is the sun, and then all of the planets orbit around the sun. For the sun's movement, the sun rotates or spins around itself. Unlike the Earth, the sun rotates faster at its equator than it does at its poles. The rate of rotation at the equator is 26 Earth days for one rotation. So that means it takes 26 of our days on Earth for the sun to rotate one time around at its equator. The rate at the poles is 34 Earth days for one rotation. So that means it takes 34 of our days on Earth, so a little over a month, for it to rotate one time. Okay, so here's a little demonstration. Okay, so the sun's north pole takes approximately 34 days to rotate. The sun's equator rotates faster, and the south pole takes approximately 34 days to rotate. So as you can see, the top and the bottom are rotating much slower than the middle. All right, gravity. It is the rotation of the sun that keeps the sun in a circular shape. This rotation keeps the forces acting on the outer surface even. It is also the rotation that causes the solar system to revolve around the sun. Due to the huge mass of the sun, it is able to keep all of the planets and other particles in orbit around it. When the strength of gravity from the sun and the gravity from the planet equal each other, they will stay that distance from each other. This creates their orbit. The sun has layers just like the Earth. Okay, the core, or the center of the sun, is 27 million degrees Fahrenheit, and it decreases the further away you get from the core. The photosphere is the layer where sunlight comes from. This is the layer of gas where temperatures start to increase. So when you take a picture of the sun or when you look up at the sun, the photosphere is actually the part of the sun you're looking at. The chromosphere is the red layer seen during an eclipse. It is red because of the abundance of hydrogen, and it is hotter than the photosphere. The corona is the outermost layer. It is only seen during eclipses, and it is the hottest of the outer layers. So the core, the temperature in the sun decreases when you go from the core outward, but once it reaches the photosphere, the temperatures actually start to increase all the way to the end of the corona. So the size of our sun, the sun is the largest object in our solar system. So here's a picture of it to scale. Here's the sun very large, and everything else around it is much smaller. However, compared to the other stars, it's only a medium-sized star. Okay, so here's our sun. A red dwarf is smaller than that, but if you look at the red giant, here you can only see just part of it. And a blue-white supergiant, you can only see just part of it, whereas our sun could fit into them many, many times over. Okay, prominences and flares. A solar prominence is an arc of gas that erupts from the surface of the sun. Prominences can loop hundreds of thousands of miles into space and can last for months. At some time in their existence, most prominences will erupt, spewing enormous amounts of solar material into space. So here's that arc we're talking about of a solar prominence. A solar flare is a storm on the sun, which appears to be a very bright spot and a gaseous surface eruption. They release huge amount of gases and are tremendously hot, from 3.6 million to 24 million degrees Fahrenheit, and they eject thousands of miles from the surface of the sun. So here's a picture of a solar. All right, and that is our sun. So make sure you've taken notes. It may help if you have drawn some pictures. If you haven't done that, you might want to go back. We will have a quiz over the sun using these notes, so make sure you have taken them, and I will see you in class. Hope you have a great evening.